Hello everyone, I'm Kong. In this video, I will show you this group tools project of Assistive Robotics. This picture shows what the smart seeing eye dog seems like in different angle. You may find that rather than our first design, we cancel the dog chin because I need it smaller so that it will be more convenient to be tested. Then, these are individual small parts of it. This is the Raspberry Pi as brain. This is the wheel and the universal wheel as the leg. This is the ultrasonic sensor as the ear. This is the camera as the eye. This is the vibration motor. This is the battery as its feed. This is buttons to give the order. And this is the speaker to inform the user. Next is the video of testing motors. I used Python code to let the motor rotate in different directions. The next is the video of testing steering engines. I used Python code to let the engines change their angle slowly. Next is the function of ultrasonic obstacle avoidance. Firstly, I click the button. We can hear a beep from the speaker. Then the dog starts moving. When meeting obstacle, the vibration motor and the speaker will work together to inform the user. Next is the function of traffic light recognition. My team member successfully did the work on computer, but I met some problems because of the performance limits of Raspberry Pi. In physical items, in order to have a better result, even I choose a easier algorithm, the Raspberry Pi could just calculate 8 times per second. Next is the show of how the camera can focus on the traffic light when moving. As you see, the FPS on screen is 8. Maybe it is not enough if we want it to really help people. But anyway, I'm happy that it worked. The video has been speeded up 3 times faster. In reality, it moved very slow because the Raspberry Pi couldn't afford the fast speed. The last video shows the process of obstacle recognition. Because it is inconvenient to use laptop and have a stable Wi-Fi outside, I tested indoor by letting the dog watching a video recorded on road by its own camera. Just simulate that it is moving on the road. We can see in the video that different from a result on computer, that it can find every car and person quickly and correctly. The Raspberry Pi processed the data very slow and missed some items. The FPS shown in the screen is 0. It means that it needs several seconds to process one frame video. So I have to pause the video by hand to wait the Raspberry Pi to calculate. Finally, it takes 17 minutes to recognize the scenes of a 22 seconds video. The video you watched is speeded up. I hope we can solve the problem in the future by using more advanced hardware such as NVIDIA TX2 or Intel Neural Compute Stick.